In this last section, we're going to focus on actually converting the equations from polar to rectangular form rather than just focusing on those coordinates, the ordered pairs, r theta and xy. So now the entire equations will be switched, and the formulas we use are the same ones we've been talking about: x equals r cosine theta, y equals r sine theta, and then the one that is based on the Pythagorean theorem, and our tangent theta equals y over x. Remember, this is the one that we actually use tangent inverse of y over x, and that's what gives us the theta value. So most of these questions will involve you having to perform a substitution. If you're trying to change your formula from x's and y's into r's and thetas, then you will just perform the substitutions shown on the top line. If you're trying to go the other way around, then it's usually the opposite. You would use the formulas down here in the bottom. So we'll look at the examples that they have shown for you guys on MATLAB again. So the first question asks you to convert from a rectangular form to a polar form. I know it's rectangular because it has x's and y's in the same way that we call the rectangular coordinates the ones that have x's and y's in them. Whenever they say change something into a polar form, then you should have r's and thetas, whether it's the coordinate or the equation form. So first thing the example has shown is just listing out the formulas that we will be using. Now I will point out that instead of saying r squared equals x squared plus y squared, they've shown taking the square root of both sides of the equation to get the square root of x squared plus y squared for r instead. So first step is to look at the formula we have, 7x plus 6y equals 13. And then, as they say, we're just going to substitute the r cosine of theta part and the r sine of theta part in for the x and y values. So that's where this step right here comes from. They're just performing that substitution. And then on the next step, they recognize that both your first and your second term have something in common. They both have an r in them. So they factored out the r, which left it in the form of 7 cosine of theta plus 6 sine of theta equal to 13. And then that's an acceptable form for the answer, so they have one of the multiple choice options matching r times 7 cosine theta plus 6 sine of theta. And that's it for the first example. This is another example doing the same process, but a little bit farther into the assignment, so slightly more difficult. Again, they have given us a rectangular equation, which means it has x's and y's in it, and they want us to change it to the polar form, so it's all r's and thetas. First thing is still that substitution. Replace the x with r cosine of theta, and they do that twice because there are two x's, and they replace all of the y's with r sine of theta. Next, they evaluated with the exponents. Be careful, since r and cosine of theta are two different numbers being multiplied together. When that expression gets squared, it squares both of those terms, the r and the cosine of theta. And then over here, it's just multiplying by the negative 10. Here you have another exponent. So again, square both the r and the sine of theta in there. Next, they rearrange the terms a little bit, because what will often happen is you'll be able to set up a sine squared plus a cosine squared somehow through a factoring step. In this case, it was recognizing that the first two terms both had an r squared in them. So notice we're not factoring r squared out of all three terms. We're only factoring it out of those first two, because that gives us a sine squared plus cosine squared, which we did in the trig identities, is equal to 1. If you need a refresher on that, it's on the identities sheet, the reference sheet I gave you guys a few units back. And this is probably the only one we'll really be using in this chapter. It's the most important one for us, that sine squared plus cosine squared equals 1, which is what they stated right here. Once you perform that substitution, then you just have r squared times 1 minus 10r cosine of theta, which is what they've written at this point. And then multiplying by 1 doesn't actually change anything. So you could just leave the equation as the form r squared minus 10r cosine of theta. Now again, this is a multiple choice, so that answer isn't on there directly. They wanted to move the negative 10r cosine of theta to the other side by adding it on both sides of the equation, and then you can see that answer choice. That's what you would be looking for on the other side. So to summarize, replace x's with r cosine, replace y's with r sine, and then look for any ways that you can factor or simplify expressions, especially if you see that there's a sine squared and a cosine squared somewhere in the equation. You might need to factor things out and then replace that with 1. Now I want you to see an example going the other way around, where they are giving you a polar equation that has r's and thetas in it, and they want you to change it to a rectangular one, which will have x's and y's. We're still using these formulas, and it's going to be a very similar process. Now what you're hoping to find is an r cosine of theta or an r sine of theta, so that you can replace it with x or y. And you're hoping to find an r or an r squared, really is my preference usually, so that you can replace it with the x squared plus y squared formula. So in this particular case, we have an r cosine of theta, which means that pair of numbers being multiplied together can be replaced with x according to our formulas. So a substitution is being done here to replace it with x, and then they're replacing the r value with the square root of x squared plus y squared. Remember that as long as two things are equal, you can substitute them to your advantage, whatever makes the problem easier. So they're just plugging that in for r instead. That's actually all they did on this question based on the multiple choice options. They didn't ask you to factor anything or try and simplify this any further. All you had to do was identify those two substitutions and plug them in. So sometimes it'll be a simple matter of just plugging in and stopping there. Sometimes you might need to perform some other operations, like maybe multiplying both sides of the equation by r, or squaring both sides of the equation. You might have to do some kind of a factoring or other math operation to get things into the substitutions you want to make. If you're just looking for r cosine of thetas, r sines of theta, and r values by themselves, you'll use this last formula on. And for a more complicated example from your assignment, this one is still asking us to go from polar form to rectangular form, but in this case we don't have any sines or cosines. However, if you remember our identities, we know that cosecant of theta is equal to 1 over sine. So if you remember those reciprocal identities, cosecant is 1 over sine, that's what they're going to be using in this next example. So again, they've listed out all of our formulas. This is the formula notation I like more, that r squared equals x squared plus y squared. The other examples we're showing is just r equals the square root of x squared plus y squared, but either of them are fine and valid to use. Okay, so once we identify that cosecant is equal to 1 over sine, then we can rewrite the equation they gave us as 7 times 1 over sine, or just 7 over sine. Well, since we have a sine of theta in the denominator of the equation, you can multiply both sides of the equation by sine of theta, which would give you r sine of theta equals 7, because on the right-hand side it'll cancel out the signs, and on the left-hand side you'll just multiply the r and the sine together. Well, at this point, we do know that r sine of theta is equal to y. That's one of the substitutions we're trying to make so that we can just replace it and then get the equation y equals 7. So that's it for what they want for the equation. However, this example is also going to ask you to pick the graph that matches this formula. Hopefully you remember from Algebra 1, when you have y equals a number, that is a horizontal line on your graph, which is what you can see here at a height of 7. If it had just said x equals 3, for example, then that would be a vertical line passing through the x value of 3. So the important part is that it says y equals 7, so find the y value of 7 and cross through that. And that's how you would pick the correct graph out of the options available. Most of this assignment will focus on these 4 equations and you guys performing a substitution from either the r cosine of thetas to the x's, or if they're asking you to write it in polar form, replace the x's with r cosine of thetas, and vice versa. So just look for substitutions you can perform, look for any factoring or things you can do to simplify. But since most of the assignment is multiple choice, I think you guys will do all right by finding the correct equation once you get the substitutions done. And that's all for the notes. Thank you guys.